Grzegorz Baran here. In this video I'm going to present how I captured and turned a real sculpture into a game-ready asset using photogrammetry. I also have some key updates regarding to my previous photogrammetry workflow about image preprocessing for photogrammetry reconstruction. In details, I'm going to present capture using Mavic 2 Pro drone, the photogrammetry reconstruction using Agisoft Metashape, 3 different ways for retopology in ZBrush, UV mapping the low-poly model in RizomUV app, and finally, using the Substance Painter, I'm going to texture the final model by applying a smart material I made for this purpose. And let's start. A while ago I decided to do a test where I do a full 3D capture with a drone. As I mentioned before, there are strict rules I need to follow when flying a drone. I need to stay away from any no-fly zones like airports, military zones, prisons or any events, as well as keep the distance of at least 50 meters to any buildings, vehicles and people. During one of my photogrammetry trips, I have found a perfect subject on site. It was a lone sculpture of Dolly Peel, a 200-year-old local hero smuggler from the South Shields. The sculpture was about 4 meters high, so quite hard to capture with a standard camera and tripod setup. It was located away from any buildings, roads and people, so it seems to be a perfect place for the drone capture. Unfortunately, the weather wasn't the best for scanning. The wind was quite strong, about 4 meters per second, so it was strong enough to affect the drone stability and sharpness of images. I was also afraid that low, direct sun might cause a lot of contrast the camera won't be able to cover within a single tonal range. Hopefully, since I didn't like the sculpture's surface, I also didn't plan to capture it with a purpose of creating a material from it. In long term, I found that it would be more beneficial to create a totally new material which can be reused on other scans like this one and turn it into a smart material instead. The last issue I noticed were birds, but due to the strong wind, I was hoping they won't risk flying in close distance. I decided to proceed with the scan despite the conditions to find out what results I can get from it, even for the price of total failure. Since the grass was quite high, I have found this scan might be also a good opportunity to test hand takeoff and hand landing. I watched a few videos before, so I knew it is doable, but also that it is never safe, especially not during strong wind conditions. So I considered the pavement nearby as a plan B in case I fail with hand landing or just if I change my mind. Setting up the equipment in high grass wasn't easy, especially after I removed a gimbal's cover and the camera lost its protection. Without a gimbal covered, the grass could scratch the camera lens and damage its mechanism during gimbal's auto-calibration. The landing pad would be very useful for sure in here, even just to get a clean, flat surface to temporarily put the drone on it. The third hand would be very useful, but since I had just 2, I had to put the controller on the ground and swipe the take-off button while keeping the drone over my head. I kept the drone with the camera facing away to myself. Finally, the drone was hovering in the air next to me. I can tell that the takeoff was a piece of cake. Of course, needs a bit more practice and maybe consider some improvements, but it wasn't anything hard at all. I was more concerned about the hand landing part I was planning to test when the scan is over, but it was a concern about the future. The next step was to proceed with the scanning. Since I was planning to scan a single subject, I used the active track feature in a trace mode. This feature allows to select the target the drone will follow. It is very useful when the object moves, as the drone maintains the initial distance and altitude. After I push the sticks to the left or to the right in this mode, the drone won't just move to the left or right in a straight line as usual, but will try to fly around the subject within the constant radius with the camera facing it all the time. I don't think this mode was designed to scan still stuff, but it seems to be perfect for prop scanning. To select the target, I simply had to draw a box with a finger on the mobile screen around the target while the mode was active. With this mode active and the target selected, the only thing I had to do was to push sticks left or right to fly around the object and release the shutter every time I wanted to take a picture. A few times, due to the strong wind pushing the drone, I had to correct the radius distance manually. Otherwise, the drone would crash. Sensors blocks the controller's order to move forward if they detect an obstacle in front of the drone, but they don't do anything if the drone itself was pushed by the wind, so it's very important to keep the drone in a distance where I still have time and space to react to the wind. After a few circles, the drone lost the target. I guess it was caused by the wind pushing the drone backwards and forward and getting too close to the target, but whatever the cause was, it was very easy to retarget the drone again and continue with the capture. After the last time the drone has lost focus on the target, I decided to simply fly around and take a few additional images from side and from the top of the sculpture. Finally, the capture was over. It took me 8 minutes and during this time I captured 75 images. The next step was to proceed with the hand landing. Before I started landing, I watched the drone carefully and have noticed a few things. The bottom sensors are placed in the back part of the drone, so when the drone faces away from me, it detects my hand as soon as I put it beneath. In result, to avoid the collision, it increases the altitude every time it detects my hand beneath. Also, the back propellers are placed a bit lower when compared with those at the front, so catching the drone from the bottom gives me less space and catching surface to actually grab the drone. It means that if I want to grab it, I need to do it very fast, before the drone even reacts after my hand is detected. And when done, I would need to hold it tight, as probably the drone will try to run away. Sounds like a finger loss recipe a bit. So I decided to change the approach. I rotated the drone the way the camera was facing myself, and since front propellers were mounted much higher, it gave me a bit more space to catch the body behind the gimbal without risking my fingers as much as before. I have also noticed that when my hand was below the drone around the gimbal, the bottom sensor didn't see it. It meant that the sensor was located at the drone's back, or that the front bottom one wasn't as sensitive as the back one. Anyway, I just had to stay away from the back one so far. I still had a few doubts, but finally I broke and I did it. I grabbed the drone behind the gimbal and pushed the altitude stick back to initiate the landing. Engines turned off and the landing was over. Unfortunately, I had no other choice as to put the drone in a high grass again, worrying about the camera safety. I think this is the part which has to be improved for sure if I consider any hand landings and takeoffs. After this trip, I did a few more hand takeoffs and hand landings, and I realized that after a few, gimbal didn't behave properly. I have contacted the DJI support then and asked to tell me what do they think about hand landing or hand takeoffs for Mavic 2 drones. Their response was that the drone hasn't been designed for any hand-based takeoffs and any hand landing, and it hasn't been tested for this purpose. And in result, I bought another landing pad, the smallest one. The one I can always carry with myself as it fits any backpack I use. So now I have 3 of them. The first one, which is 75 cm wide, it's quite small and it doesn't leave any space for any landing errors when used. In my last video you can see that I almost lost a blade when it hit the stake after being pushed by the wind. The second one is 110 cm wide. This size works very well for Mavic 2 Pro drone. The issue with this one was that it's very big even when folded and doesn't fit any of my backpacks. The only solution to carry it is to attach it outside of the backpack. In result, I started carrying the small one again instead to finally order the last one. So now I am a bit confused which one is the best to use. In result, I decided to use Mavic Pilots.com forum and ask more experienced Mavic 2 drone pilots to myself to get their opinion on hand takeoffs and hand landings. So far, I was told that many of them do hand landing and hand takeoffs since years, and their drones are totally fine and they never had any issues with them. It means that the last landing pad might be the only one I use, since it's very easy to carry and fit my backpack. But I believe I'm going to use it mostly as a flat, clean temporary surface to set up the equipment and don't risk any gimbal or camera damage. Not sure if I use it as a landing pad itself, since it seems to be too small, but who knows, we'll see after a while. Now I have a choice and I believe time will show. Despite the capturing conditions, captured images look quite good and are ready to be used as a source for photogrammetry-based reconstruction in Metashape. To do this, I need to bring all those images into the software and start the process. Since I'm not planning to create any texture from captured data, I'm going to use pure DNG files without any post-processing and any fixes. I will expand the topic in a moment, but currently let's just load all selected images. The Metashape can score each image quality for reconstruction. It can be done in Detailed Photos view by running Estimate Image Quality feature. This is the moment of truth really for the capture I made. Image quality below 0.5 means that image is useless and has poor quality. The image scored as 1 has the best quality. Everything between 0.5 and 1 is okay. The closer to 1, the better. As you can see, most of images is scored around 0.8, which isn't bad in this case. Just a few are around 0.5, but since I didn't plan to capture a surface material, for the purpose of this reconstruction it is a very good score and all images are ready for the next step. A photo alignment. In this step, Metashape finds shared points from each image and estimates its position relative to the camera position the image was taken from and other images. I have used all images as DNG without any preprocessing in any photo editing app intentionally, even if Mavic 2 Pro has terrible barrel distortion. I usually used to fix the distortion in photo editing app until someone pointed me out that I might be wrong and it might not be a good thing to do. By fixing barrel distortion before photogrammetry reconstruction, we trim the image and remove part of the data. Depending on how big distortion is, it can be from almost nothing for aspherical glances to even a few percent of the entire image for those used by drones. This data might have an impact on image alignment. As long we have a lot of image overlapping, it shouldn't be a big issue, but less overlapping we get, the more relevant this data can be for the alignment process. But that's not everything, and consequences of barrel distortion fix can go even deeper. Since the photogrammetry software estimates 3D coordinates using mathematical models, the results are usually more accurate to what photo app-based undistortion feature can deliver. Additionally, the photo editing app undistortion feature is usually measured with grid transformation, what introduces additional non-linear, unpredictable distortion within the image. So, by fixing the distortion in photo editing app, we remove some useful for image alignment data, but also introduce unwanted perspective noise. To dispel that, I have spoken with Agisoft and Reality Capture guys, and they confirmed that. It means that it is way better if any image perspective distortion is fixed directly by photogrammetry app, and fixing it by photo editing software is not recommended. If from any reason we decide otherwise and fix the barrel distortion using any photo editing app, it is suggested to fix all the calibration parameters in camera calibration dialog to avoid the calibration coefficients being estimated again. On the occasion, I have also learned a new very important thing. Finally, in Metashape we can process the images in the original color bit depth, and it will be treated properly at every processing stage without any internal downsampling to 8 bits. Metashape supports DNG and CR2 RAW formats, but to avoid the bayering, which takes additional processing time and increased memory consumption, they can be converted to TIFF. It simply means that for cases like this one, we can simply use pure raw file data without any color depth and dynamic range tweaking, as the Metashape sees, read and utilize all necessary information from raw file for us. Of course, in case of standard material capture, when we need to calibrate the color, set up the white balance, push up blacks to reduce ambient occlusion shadows and reduce highlights, those tweaks are still beneficial and are a must. After the photo alignment process is over, we can see the cloud of shared points and camera's position when camera position preview is active. Since we don't want to reconstruct entire scene, just the sculpture, we need to limit reconstruction area with the region box just around the sculpture. When done, we can proceed with next steps. To do this, I simply set up a batch process and added tasks I wanted to be processed. The first one was to generate a dense cloud. I wanted it to be generated just to show you the reconstruction complexity when it is done. The dense cloud can be previewed in real time. Previewing 70 million dense high poly model in preview window isn't as responsive as previewing a dense cloud. So the next step was to generate real high poly mesh. It can be based on dense cloud, but I used a new reconstruction method Metashape offers, which is called a depth map based reconstruction. The last step was to simply export the reconstructed high poly model and store it in FBX format. This part takes a while and depends on amount of images and processing power we have. Might take an hour, but might take even a few days. Those 3 steps set with the batch process took something around 1 hour on my computer. In result, I had a heavy high poly model with gaps, and I'm going to use it to bake the high poly information from. Because in the next step I planned to build a low poly model in ZBrush, I decided to create a lighter high poly version of it, the one I can actually work in real time with. So I used a decimate mesh tool Metashape offers to decimate the high poly model down to 15 million polys. When it was done, I saved it as another FBX file. As you can see, there is no much difference between the very high poly model and 50 million dense one. Especially the 15 million one is going to be used just to define a low poly silhouette for baking. Just one more thing. These are positions of the camera when the reconstruction photos were taken with a drone. Let's jump into a ZBrush to create a low poly model. The first thing is to load the high poly model, which is going to be used as reference for low poly shape and positioning in 3D space. As I mentioned before, to get decent real-time response in viewport window, I'm going to load a 50 million poly heavy one. In result, we want to get a low poly version of this model. The first step we need to do is to fix it by closing any gaps we have. There are a few ways to make sure model is solid and has no gaps, but I believe the best one in ZBrush is simply to dynamesh it. This way ZBrush projects the even and closed geometry around the object from all directions with set level of density. This way we get totally non-optimized but clean and closed geometry, which is a great start to build a final low poly model. It is still way too heavy to be used in any real-time engine, but is a great starting point. There are a few ways to do retopology in ZBrush, and I'm going to present you just 3 of them. As always, the best one is very time consuming and needs a lot of experience. It's manual retopology. This way we need to redefine entire topology edge after edge and polygon after polygon. The best way to do it in ZBrush, in my opinion, is to use topology brush. With this tool we draw lines on a surface, and every time line intersects with another line we get a vertex point. A face is being created when there are 3 or 4 vertex points connected to each other with lines. As I mentioned, manual retopology is very time consuming, but usually gives the best results. This is the best way we can really get exactly what we want. Manual retopology makes sense for characters when the model is going to be animated and where every polygon counts. But in this case it would be a waste of time and effort, since what we really need is a simplified mesh which keeps the shape and can be easily UV mapped. So let's say we want to automate retopology a bit. To do this, ZBrush offers two very good tools to play with: ZRemesher and Decimation Master. ZRemesher is something between manual retopology and totally automated one. It can do fully automated paths, but it also has tools which helps user to communicate with the tool. The most important one is ZRemesher Guides brush. With that brush we draw lines which are going to be used as a guides for reconstruction. Depending on priority setting in ZRemesher tool, the tool will try to follow them during the reconstruction later. The second important feature is the color-based density. The idea behind this tool is quite simple. Everything without any paint is considered as a standard density. Areas marked with pure red or set by the color density slider to 4 are going to be 4 times denser to unpainted areas. A setting to 2 doubles mesh density. If the slider is set to minimum available value, which is 0.25, the color will be blue and the density of the mesh will be quarter to unpainted one. After we finish the setting, we need to hit the ZRemesher button and the tool will generate a new topology for us. This way we get the model which is easy to UV map, but isn't optimal as it is often still pretty heavy from mesh density point of view. And this is where the last tool comes in handy, a Decimation Master. Decimation Master tool is located in Z plugin tab. For organic objects like sculptures or rocks, decimation seems to be a very good choice. Decimated model usually keeps the shape very well with the more optimal polygon count. The downside of decimation is that it's quite hard to UV map when it's done. But since I'm going to use RizomUV for UV mapping and Smart Material to create a final texture at the end, complicated UV mapping process shouldn't be the case anymore. So let's decimate our model until we are happy with the result. And when the model is ready, let's export it as an FBX file and jump into the RizomUV to UV map it. The next step is the UV mapping. Usually, UV mapping is quite hard and ungrateful task to do. Depends on many factors like the geometry complexity, geometry flow, texture type and resolution, and many others. Unfortunately, the final result depends on this part, and at least for myself, this is the part which is never fun, and this is where RizomUV comes in handy. This tool can do all the hard UV job for us within a second. What we just need to do is to bring our model into the RizomUV viewport and ask the app to do UV mapping for us. We can go full auto with the auto seams by selecting of what type of seams we want and how we expect RizomUV to deal with them. In this mode, we just need to do a few things. Select the type of UV mapping which works for our model the best. press the button to calculate seams, press another one to do the UV mapping and flatten the UV islands, and press the last one to pack up our result within a single UDIM. Of course, in the first step we can tell the RizomUV app what we prefer. More cuts and more islands, but less stretching, or less islands, but at cost of more UV distortion. In preview window we can live preview the result and see the heat map, which represents UV squashing and stretching. Since for this case I'm planning to use a smart material to generate a texture, I can have as many cuts as needed just to avoid UV distortion. To save UV mapping, I just need to press Ctrl and S or select Save from Files, and the UV mapping is done. Of course, there's way more options to play with. We can modify seams however we want to, as this software is really very powerful. As you can see, we have some squashed UV space on the base. We can easily add a few more seams or rearrange existing, and ask RizomUV anytime to take them into consideration. Finally, we remove the stretching at the base and entire UV mapping looks fine to proceed with the next step. Let's resave the changes and jump into Painter for texturing. The last thing which left me to do is to build the final set of textures for the sculpture. To begin with the texturing in Substance Painter, we need to bring the low-poly model first. As I mentioned at the beginning, I didn't like the original surface of the sculpture. It didn't look very well and was quite hard to read. I decided that it would be more beneficial to replace it even with something simple, but with better surface definition. I think that something like universal old weathered stone would be the best pick for this sculpture. Also, because I wanted to have an option to apply this material to any prop I make, I decided to go with a smart material as a tool. But to make sure any smart material can be applied properly, I need to bake maps for the high poly model, which also will work as a guide for smart material based texture generation. With high poly model based textures baked, we can finally apply a smart material. Smart materials can be found in Smart Material shelf. But since I didn't find anything which works for me, I made one by myself. To add it into Smart Material shelf, it has to be dragged and dropped into the Substance Painter. After that, it can be applied into any material into the Layers tab. This smart material has three components I made in Substance Designer: a base layer with old stone surface applied, a weathered stone surface which should appear on edges, and a moss layer which overlays everything to weld it together and emphasize the aging and weather effect. I have also exposed a bird's poo, contrast and saturation for stone surface. For moss, I exposed the moss hue, so I can change the color if needed. I can play with sliders and masks to tweak it in direction I want, and play with the display settings to increase contrast and improve how the final result look like, but there is no much left to do since after the texture was generated, it is simply ready to go. The textures just need to be exported and the process is over. I have created this smart material just as an example of how powerful this tool might be and how much work it can save if well used. Of course, the smart material can be even more complex and can be mixed with other smart materials and other materials, but I think this is a topic for a different video. I hope someone found something useful in this video, and if you want me to create even more videos like this one, please press thumbs up, subscribe to my channel, or just drop a comment. Big thanks to everyone for support, as it really helps me to move forward and share more content with you. Thanks for watching, and till the next one. Bye!